All right, before you start this video, I want you to grab these supplies. One ruler so you could draw straight lines as a straight edge. One regular pencil. Two colored pencils. I have red and green. And you can print the protractor picture that we posted. That's kind of a tongue twister. Print the protractor picture that we posted. Or if you have a regular protractor, you don't actually need to have the ruler with you, okay? Because this can act as a straight edge too, okay? So I'm going to put those supplies to the side, go grab them, and then come back. All right, now that you've come back, we can start the video, okay? This is called the law of reflection notes, all right? We're going to learn a mathematical rule for how light reflects off of mirrors, okay? So we have to start on the right side. I wrote down the three definitions that we're going to fill in the blank for here. And we're going to start with something called the normal line, all right? And here on the left side of your paper, you could probably put this on top of your notebook page and this on the bottom of your notebook page because yours isn't landscape like mine. So this on top and then the definitions below. But on the top, you're going to put on the left side something that's a straight vertical line and write down the mirror surface, all right? And draw an X somewhere above that word so you can, you don't have a mirror at home, but basically we're pretending for you that the mirror is right there, okay? Now, you also don't have a laser at home, okay? But eventually you're just going to trace those lines and just do your best to recreate what I have here, even though it's not going to be perfect because you don't have the laser that I have, okay? Okay, so let's start with the definition of the normal line, okay? Since the mirror is going to be right here and the X is right where the mirror sits, the normal line, normal just means perpendicular. It's a line perpendicular to the mirror surface. So 90 degrees, in other words. That's what we mean by perpendicular, okay? 90 degrees to the mirror surface, okay? So this is where you need your protractor, okay? Or you have lines on your notebook and that might help too, all right? But if you want to draw a normal line, what you have to do with your protractor is see this little dot right here? That has to go right on the X. And the dot actually has some crosshairs up and down like that. Okay, so those crosshairs lie flat on the mirror surface, just like that. Not tilted like this, not tilted like that. The crosshairs lie flat on the mirror surface, and this circle is right above the X. Now go find the number 90 and put a dot right there. Okay? Sorry, my table is a little shaky. Once you find that dot, connect that dot with a dotted line back to the X. So that dot was where the number 90 was. And that, write it over here so it doesn't get in the way, write down normal line all the way on the far side of the page. All right? And there's a 90-degree angle there between the mirror surface and the normal line. All right? Now, we're going to draw the light rays and how the light reflects off of the mirror. Here's my laser, and I'm going to try to... Here we go. I'm going to trace those lines. You do your best tracing those lines without a mirror, okay? I'm going to do one line, basically like this, that is green, heading in towards the mirror. So I could draw some arrows with that light heading in towards the mirror. I'm not going to move my laser because I don't want to mess it up here. And I'm going to draw some red lines for the light that is reflected off of the mirror and then heads away from the mirror, okay? So this goes towards the mirror, then that goes away from the mirror. And now I could take my laser away. And I have those green lines and those red lines. And I want to take my straight edge and my protractor. At this point I could take that away. and I'll make one straight line through those, okay? You just want that straight line, and then do your best to approximate, even though you don't have the laser. Do your best to approximate, oh, that's where the red line should be, heading away from the mirror. And those two rays have special names to them. This ray heading towards the mirror is called the incident ray. So incident ray means incident means towards. It's incident upon the mirror, means it is going into the mirror, okay? Incident means towards. I-N-C-I-D-E-N-T, okay? Incident. And then the red one is heading away from the mirror, so that is after it hit off the mirror, so it is reflected, okay? Let's see if I could... reflected. Well, I almost finished the word. Reflected ray. So that the reflected ray is the one that heads away from the mirror, and I use those arrows to help indicate that, right? Now, there's a geometric principle that if you know how the light is heading towards the mirror, well, you could see that if the light is at a wide angle like that, it also reflects at a wide angle. And if it's even wider, it's even wider when it's reflected. But if it's a narrow angle like that, that's close to the normal line, it gets reflected sort of close to the normal line too. So you could see that there's a relationship between if it's really wide, the reflected one's really wide. But if it's really narrow, the reflected one's really narrow as well. And so we're going to start measuring angles. All right, there's two angles that you need to know: angle of incidence and angle of reflection. So the angle of incidence, we need to know how to measure that. It is measured between two lines. Measured between the normal line and incident ray. Measured between the normal line and the incident ray. Okay, so where's the normal line? Here. And where's the incident ray? Here. Normal line, incident ray. So the angle between those two lines right there is the angle of incidence, right? That I swept out right there. The angle of incidence is represented by the symbol theta I. I is a subscript saying it's angle I. I for incidence. So theta I is right there, okay? Now the angle of reflection is measured very similarly. It's measured between the normal line again. That's why we drew that normal line to start with. And the reflected ray. So incident ray, reflected ray, normal line, okay? So this is between normal line and reflected, so that angle is right there. And that angle is, again, represented by the letter theta, but this time we call it theta R for reflected. Right there is theta R, angle of reflection. Okay, so let's push that upwards just a bit. And we need to write down what the law of reflection is. The law of reflection says that there is, this is your reasoning section here, the law of reflection. Just to let you know, next 2 weeks, 2 cycles, you're going to use this for reasoning sections a lot. The law of reflection states that the angle of incidence is always equal to the angle of reflection. Let's write that out in words. Angle of incidence equals the angle of reflection. And you could look and see that the size of this angle and the size of this angle are approximately the same amount. But how can we tell with numbers? All right, write that down before to tell what numbers. You could pause if you want. All right, how do we tell with numbers that these two are the same? The law of reflection says that. Well, we could measure them, okay? And to measure them, take your protractor now and do what I do, just along with me to practice. So take your protractor, and first we're going to measure the angle of incidence right here, okay? We're going to measure that. Put your dot on the X, but put it like this time. Why? Because we need to have the normal line as one of our lines we're measuring between. So the dot has those crosshairs on it. Let me show you again. Those two crosshairs. This time we're going to lay those on the normal line. Not like this, not like this. Just lay those crosshairs right on the normal line and the dot right over the X. Okay, and you're going to see if you look to the right along the normal line, there's the number 10 here, 20 here, 30 here. So if you count backwards, 30, 20, 10, the number here is really 0 on the protractor. Right on that line right there is the number 0. All right, so count upwards from 0 to where? From the normal line to the incident ray, says the definition of the angle of incidence. So normal line is at 0, 10, 20, 30, 40, wow, 45, exactly, almost right there. So it looks like in my example that the angle of incidence was 45 degrees, and yours might be a little different, and that's okay. And since you freehanded it, you might not get the exact same number when we do the angle of reflection. You might not get the same number as you got for incidence. I think I'm going to get pretty close to 45 degrees because I used a laser. All right, so again, put the dot, the hole right above the X, and your crosshairs right there. Put that on the normal line, because now we're going to measure the angle of reflection. So for theta I got 45 and I held it like this. Now I'm going to flip it over so I could count up to the red line, count the angle up to the red line, but count it up to the red line from where? From the normal line, because normal line to reflected ray is how you get the angle of reflection. All right, so if you look at that there, again, look at the numbers on the right. I'm going to do it this way. Look at the numbers on the right side of your ruler. You could see 40, 30, 20, 10. What number do you think is right there on the normal line when you lay the crosshairs on it? Is 0. You got the hole right above the X, the crosshairs along the normal line, and you could see that 30, 20, 10, and that right there is 0 on the normal line. So that means you could count up from there, up to the red line. Now let me try to do it and see what I get. 0, 10, 20, 30, 40. Oop, looks like 46 that time. Pretty close. Pretty close. My theta I and theta R, not without some errors, right? But those two angles should be pretty equal. You measure one like this. All right, crosshairs on the normal line. And then you measure the other like this, okay? I guess what it's important is when you go measure them, some people make the mistake of, even if they have their crosshairs on the normal line, they can't start counting the big numbers like 170, 160, 150, 140. So I'm going to just let you know. So ignore, when you use your protractor, ignore any numbers above 90 degrees, because we're dealing with acute angles here. Oop, you didn't see that. I wrote it here. Ignore any numbers above 90 degrees, because both of these angles are always going to be acute. You could just assume that when you lay it nicely like that, you could count the angles that are below 90 degrees, not 170, 160, 150 like that, okay? All right, guys. So I understand your angles probably didn't come out exactly the same when you measured like this and then flipped and measured like that. But hopefully they were pretty close. But you didn't have a laser, so it's okay.